do would be to welcome you to the first of our series of podcasts where we explore the views of senior members of the rail industry on issues that are going to have a significant impact on our future and in which DGauge are actively involved. As many of you know, I've been raising the issue of the government's legal commitment to net zero carbon by 2050 and the potential role that rail electrification can play in this for some time now. I firmly believe that as an industry, we can provide a relatively quick win in converting renewable energy into motion compared to the issues involved in, say, building a complete electric vehicle infrastructure. We're very fortunate to be joined today by Peter Dearman, a legend in railway electrification and who I've known since the days of East Coast Main Line electrification some while ago. And I hope to explore Peter's views on the future of electrification and as a result understand some of the challenges we face in getting our present electrified mileage above the 38% that we presently have. So welcome, Peter, and thank you for giving us your time.
Well, David, thank you for giving me the opportunity to take part.
Pleasure. So let's, since times on these podcasts is quite limited, I'd like to get straight in with the first question that I want to ask you, which is what's your view on the extent of electrification on the UK network and how should it change given the future landscape?
Well, of course, we are limited by the history of electrification, which in the UK has been stop-start by nature. In the past, there have been various attempts, three major attempts to establish a programme of the widespread electrification across the network. That was the 1955 modernisation plan, followed in the 1970s by the option 5 proposals of BR. And then in Network Rail days, we had the NEP, the Network Electrification Programme. The only reason I raise those is because there is and has been for many years a clear understanding that electric traction is superior in many ways. And the case has been made 3 times now for widespread electrification, and 3 times we have failed. However, we now face, with the climate emergency and the need to respond to decarbonise the economy, we face the need to make traction decarbonisation work. So we have a 4th opportunity here. There is enthusiasm about electrification. We as engineers must respond to that and make sure it happens.
Thank you. Yeah, interesting viewpoints. Obviously, we're seeing that this climate change is really forcing a lot of hands to take some action, and really 2050 isn't that far away. And I think there's a number of people really want to see it even closer than that, to be absolutely honest. But I mean, one of the things, of course, that we're renowned for is the cost of electrification. It's always been used as an excuse as to why we didn't finish some things off and things like that. So what's your thoughts on how we can reduce the cost of electrification?
Well, CP5 experience was not happy. The well-documented problems that occurred with the CP5 schemes have kind of poisoned the well a little bit about people's thoughts about electrification. The reality is, of course, that electrification today is still what it was at the turn of the century. It's the need to put structures, wires, switchgear, connections, cables in place to put the wires up above the track. So the real nature of it has not changed very much. So what we need to explore in answer to your question, I think, is why East Coast Main Line at the end of BR's time completed a year ahead of budget, a year ahead of programme and under budget, whereas we have seen Great Western woefully outside its budget and late. The equipment hasn't changed. Masts, steel, wires are all still the same. So it must be something about the implementation programme. And there's something I think that needs to be addressed in answer to your question, how do we reduce costs, is by getting a better understanding of the commercial, contractual and programme management issues that lead to a finished electrification scheme. And one of the real big lessons that BR learnt painfully, but learned, was that the so-called route rationalization, resignal, then electrify principle was important to maintaining the production costs of electrification low. What it means is clear the civils works, clear the signalling works, and then and only then put your electrification production resource on the track. Great Western suffered from intertwining and interdependencies between functions. So I think there's work to do to get to a rational implementation strategy, and I think then we'll see the cost of electrification tumble to where they need to be.
Interesting. Do you, to how much do you think that the standards get blamed for some of this stuff? Do you think that TSIs and national standards need to be revisited at all?
That's a very interesting point, isn't it? I don't think very much is the answer to that. I think the standards are, broadly speaking, where they need to be. People cite the TSI as a cause for concern. I don't really share that. Some of our national standards need some work to bring them up to date, but that's not fundamental. What is essential is that standards don't become a vehicle for people trying to dictate a fixed one-size-fits-all solution to every possible scenario, nor should it be a cause for individuals who have particular engineering preferences for configurations and solutions. I don't believe that the standards do that per se, but I believe they get interpreted that way. So I don't think there's a lot to do, to be honest. I think we just need to work them and work them with the right cultural view that we want to achieve compliance at zero cost.
Okay. Now, of course, we've probably, looking at the rail network, already picked up a lot of the low-hanging fruit in terms of routes that are relatively straightforward to electrify. But when we start to look at things like the Pennines, we've got some really difficult structures to deal with. So I'd be interested to know what your views are of how we actually should electrify some of the really difficult structures that we've actually got to do if we really are going to go for seriously increasing the amount of electrified network.
Yes, it's an interesting point, David. Any electrification scheme will, of course, entail some civil engineering works on some bridges and some tunnels. But that is not something that should apply to every bridge and every tunnel. Clearly, it is impractical to rebore and rebuild every bridge on the network. What's interesting about TransPennine is that even given the difficult conditions that exist in the likes of Standedge and Morley tunnels, we have found that by application of best modern practice, we can achieve clearances which are acceptable. And there are two parts to that equation. The first is DGauge, the statistical analysis of clearances and the ability to look at it from a probabilistic point of view and reduce the amount of clearance works necessary through that method is vital. But the second part is the work that's emerged from Great Western on voltage controlled clearances. In combination, those two techniques allow us to move to a hugely reduced scoping of works to get through some of these Victorian structures. And I think it's important that we apply those methods as widely as we possibly can.
Thank you. Obviously, just looking at the program, I mentioned at the beginning that I think we're 38% of our network is currently electrified. I think that's the latest figure that I've seen. The implications of a very large program of electrification are going to be quite high, given that we've got to achieve something significant by 2050, over 30 years. What do you think those implications are in terms of an enormous program of electrification?
Well, I think there are two which are exercising my mind a lot at the moment. The first is that it would be a mistake to look at some 15,000 kilometres of wiring, which is what the decarbonisation initiative indicates as being required, and to try and do that in a short period of time would be a catastrophic mistake. We would try to mobilise on too many fronts and we would exhaust the supply chain capability very quickly. So we have to take a view that says we're at 2020 and we're looking towards a 2050 time horizon. We have 30 years to achieve this. If we can do our level best to spread the build across that 30 years, we end up with somewhere around 500 kilometres per year being delivered. And that starts to look like the sort of rolling programme that the Germans have achieved for the past 40 years. So I think that that process of looking at how we roll electrification out in a controlled way that doesn't swamp the supply chain is very important. A component of that is recognising that bi-mode trains that we've bought, the diesel bi-modes, may be suboptimal in the long run, but they do give us the perfect opportunity to progressively roll electrification forward. But there is a second aspect, which is also something that I'm spending some time on, which is traction power. We will be growing our electrical demand as we shift the emphasis from road-borne freight to rail-borne electrically hauled freight, and we increasingly scale up the passenger operation across lines that are currently diesel. We will be imposing greater load on our generating capacity in the UK. To get to a situation where that generating capacity keeps pace and provides supplies at the points where the railway need it, means we need a traction power strategy. And that traction power strategy is something that I am actively working on, particularly for the north of England, where of course there are a predominance of lines in the northeast still running by diesel trains. If we can inform that strategy and convey our needs to the distribution network operators and the grid, we stand a fighting chance of making sure that the green energy generation is available at the places and at the times that we will need it.
Okay. Of course, the other thing, if we start to look at power, we've also got a 750 volt DC network, third rail. And there's a lot of questions over that, not the least being the Office of Rail Regulation feeling that, for example, we shouldn't be extending that for safety reasons. But so what do you think is the scope for third rail electrification? Will it survive? Will it expand? What do you think?
Well, I think there are a couple of practical issues that one has to take into account here. The DC network is quite large at the moment, 4,000 kilometres of it, roughly in operation around the nation. And to consider converting 4,000 kilometres at the same time as you're trying to put new electrification over 15,000 kilometres of non-electrified routes would seem to me to be irrational. We already have an electric network. It has some limitations, but it's perfectly serviceable. Personally, I think now that the DC network has a long future, and I think it will need to be extended to cover those parts of the lines which have, even since 1917, have sat there without conductor rail on them. So my view is the DC network will survive a long time into the future, foreseeably, and I think we have to cross this largely emotional hurdle about the safety risks that extending it brings.
Okay. And I've got one final question I'd like to ask you, because we're seeing a huge amount of innovation these days. And what I would say is there seems to be a lot of faith being put into both battery power and the use of hydrogen power. Certainly, we've seen hydrogen trains recently going on the network, and battery power is certainly something that's been touted as being a way forward of achieving electrified traction where we don't actually have wires. What do you think about these new methods, and are they really going to make a substantial difference to what we see in the future in relation to a properly electrified network or one that's only part done?
Personally, I have some quite serious reservations about both those technologies in terms of their application on rail. Let's dwell on hydrogen for a minute. Hydrogen isn't a mineral that you can mine. You have to manufacture hydrogen for any use, and for traction use particularly. The manufacturing of the hydrogen is tremendously energy costly. The embedding of energy into a hydrogen supply takes 5 times the energy you eventually end up embedding. So for every kilowatt that you take away to a train, you have wasted 4 kilowatts of energy. You also have to transport the hydrogen, and it's only 20% of the energy density of diesel oil, roughly. So the tanks get much bigger. It may have a place marginally on small branch lines and small parts of the network. It will never, I think, deal with mainline heavy haul trains. Batteries, I have a different set of concerns about. Batteries are based on the use of rare earth metals, and rare earth metals have a clue in their name. Those batteries and the rare earth metals of which they're built will become a major supply demand for automotive industry. Cars, insofar as they exist into the future, will be electric only, battery powered. They will take up the market, the available market for batteries. The other point about batteries on trains is that I still am unconvinced we will get the range of operation much above about 50 miles. And the charging time at the terminal end, at the 50-mile terminal end, will, I think, make operation of EMU type turnaround that we experience with normal traction as being something that won't be achieved. The train will have to stand still for an hour or so to recharge itself before making the 50-mile journey back. So my own view is they may have a place, batteries and hydrogen and other technologies which may emerge, of course, but would you bet the farm on them being ready for 2050? And will they make the difference to our transport infrastructure that we would hope they might? I doubt it.
Thank you. Some really interesting views there. So Peter, that's great. Thank you so much for talking to us. I'm sure we could have gone on for an awful lot longer than that, but it's certainly given us a bit of an insight into your thinking. And I'm sure this is only part of the debate. And once this is published, I look forward to hearing comments from people who might want to say something about what you've said and the questions I've asked. So we'll see what comes out of that. But to the audience out there, I'd just like to say thank you for watching this, and we look forward to seeing you on our next podcast. Thanks.
Thank you, David.
Thank you, Peter.